All right, good morning, students. This is a lesson on how to analyze minerals in terms of identifying them. So we want to be able to identify, for instance, between these two minerals. They look very similar. Could they be the same mineral? That's kind of what we're talking about today. How do we actually identify a mineral? If we're going to review minerals just for a minute, they have 5 properties. And the last two are really going to be very important today, the crystal structure and the composition, because those two things are going to play a key role in how we use tests to be able to know what a mineral ultimately is. Okay. The 4 mineral characteristics, or like the 4 tests that we use, we look for its luster, we look for breaking patterns, we look for streak, and the hardness. Okay, so if we know those 4 things about a mineral, we can start to identify what it is. When we say luster, we're just talking about how a mineral reflects light. So a metallic luster looks like a shiny metal, like this galena here looks like a shiny metal. Non-metallic luster, it's just dull. It does not have that shiny metallic look to it. It's really not much more complicated than that, and you never want to make it more complicated than that. Either looks like a shiny metal or it doesn't. Okay, next one is breaking patterns. This one's particularly challenging for students because being able to distinguish between, well, is this mineral cleaving or is it fracturing, can be tough. So let's just go over some examples. Like over here, for instance, this mineral has really nice cleaving patterns. And we can tell that because of those flat surfaces. It looks like it's been cut. It's got recognizable shapes and patterns. Whereas the mineral over here on the right, it's breaking randomly. We don't really see any pattern to it. So again, a mineral can either have cleavage as its breaking pattern, or it just fractures. It has no pattern at all. And how a mineral breaks is determined by, let's go back to it, how the arrangement of the atoms is. How are these, how the silicate atoms, how is the silica tetrahedron put together? So for instance, if the silica tetrahedron are arranged in sheets, then we'll get a breaking pattern that's in sheets. So you can see this biotite mica, it breaks off into these thin sheets. And we would call that one direction of cleavage because it gets cut, it cleaves itself in one direction. Calcite, for instance, it has a different arrangement of atoms, and you can see how it's breaking. It's got 3 directions, and they're all at a non-90-degree angle. So you can clearly see these are all different examples of calcite. It looks kind of like a rhombus that's kind of tipped over, right? And 3 directions of cleavage, cubic cleavage. These are cubes of halite, or just, rock salt. And you can see it grows in really nice cubes. Again, the arrangement of the atoms is what's actually causing that. The atoms are arranged in a way that allows for it to break in these 3 directions at 90 degrees. Okay, the next test is streak. You basically just take the mineral and you rub it over a white porcelain plate, and if it leaves a color, it's got a streak. You can use the color to maybe try and figure out what the mineral is, because some minerals have a very distinct color, like cinnabar, for instance, has this really nice kind of dark red, almost brown to it, and pyrite has like this, almost like this greenish brown color. It's very, characteristic of that mineral. So streak, you take the mineral, you wipe it over over a white plate. If it leaves a color, it's got a streak. The last is hardness. Now, hardness is something that we're all familiar with, especially with your cell phones, your electronics. You don't want them to be scratched, and I'm sure all of us are very cognizant about where we put our cell phone. You would never put your cell phone in the same pocket as your keys, because you know that the metal on your keys could easily scratch, say, different parts of your cell phone. So we're already kind of familiar with how that works. So if a mineral is hard, if it's considered a hard mineral, when you scratch it against a glass plate, you'll actually see a nice deep scratch. All right, if the mineral is considered soft and you rub it against a glass plate, you have to physically rub the mineral up against the glass plate. If you don't see anything there, it's considered soft. The hardness of all minerals can be plotted on what's something called Mohs hardness scale. So here's Mohs hardness scale. The softest mineral being talc, the hardest mineral being diamond. And as you might expect, harder minerals can always scratch a softer mineral. So that's the rule. If minerals are equal hardness, they actually can scratch each other. So for instance, a diamond, what can scratch a diamond? Well, only a diamond can scratch a diamond. Diamond can scratch everything else. Nothing else can scratch diamond except itself. These over here on the right are the hardness testers. You can actually use these as a way to kind of get an approximate idea of what the hardness is for a mineral using those tests. So like your fingernail, for instance, has a hardness of 2.5. Your fingernails are actually pretty soft. A glass plate has a hardness of 5.5. So if a mineral does scratch a glass plate, that means its hardness is either equal to or greater than 5.5. If it does not scratch the glass plate, it's less than 5.5. That's how that works. This is page 16 of the reference table, and it has a lot of information. Let's just go over it. I couldn't put the whole thing on there, so I'm just going to show you as much as I can. On the left column, we have luster. These are all metallic. These are either, and the ones below there are all non-metallic. Most of the minerals on the chart are non-metallic. All the hardness values are here. It tells you cleavage or fracture, depending on the check mark. Common colors, because there are common colors to the minerals. Some minerals tend to have the same color over and over again. Like galena, it's always metallic silver. Pyrite tends to be a brassy yellow color, things like that. These are some other characteristics that might be very specific to the mineral. For instance, talc, it typically has a greasy feel. Muscovite mica, when it breaks, it's thin, flexible sheets, things like that. It tells you its uses, commercial use, industrial use, like graphite's used in pencils, pyrite's used for sulfur ore, selenite gypsum is used for drywall, so a lot of your homes have drywall as the wall material. That's a pretty weak material actually. If you were to knock into that, you could actually break it pretty easily. I wouldn't recommend trying that though. Composition, this is just what elements are in that mineral. Okay, so galena is lead and sulfur, so it's a lead sulfide. Down here, talc is pretty complicated. It's magnesium, it's silicon, oxygen, and hydroxy. Sulfur is just, sulfur. It's only got one thing. And last one, halite, is sodium chloride. I happen to know what the elements are off the top of my head, but you can look them up all the way in the bottom of the chart. It tells you all the elements, so you can always know what elements are in a particular mineral. You don't have to have an understanding of chemistry or the periodic table. You can just look it up. All right, that's it for today's lesson. I will see you all tomorrow.